Here, I'm going to solve this example by assuming every current is going out of the source. Okay, so I'm going to take the current flowing here as I1. I'm going to take current flowing here as I2 and current supplied by the source as I3. Okay, so those are the three currents I'm assuming. But the loop analysis is a little bit different than what I'm doing. I will solve this example by using loop analysis also. So here, according to my current direction, in the 20 ohms, current is entering here. So this must be positive. This must be negative. Now, this 10 ohms here in the middle, I2 current is entering here. So this must be positive. That must be negative. And here, it's a I1 current in this branch. So current is entering there. That's positive and negative. Now, when it comes to I3, I'm going to use different color here. Let me use red. So according to my I3, current is entering this terminal. So entering terminal is positive, leaving is negative. Current is going to go through and I3 is going there. I3 is going in this direction. So plus and minus.
And sorry, so we're assuming the I1 near the 20 ohms near the bottom is I1 because it's connected in the same circuit as in positive and negative.
That is right. So
Okay.
since, yeah, we are assuming I1 current is supplied by this 20 volt source, the current flowing in this branch, in this loop. So here you have these three. Okay, so whenever I said I1 current is passing through this 20 volt, for sure the same current is coming here and the same current is leaving there.
Okay, that makes sense.
So here, according to my current direction, this must be positive, negative, and this must be positive, negative. Since this is a source, the source definitely have positive, negative. It's a given by the source. Okay, any questions on that? Any questions how I assign the positive, negative signs for this?
No.
Okay, sounds good. Now what I'm going to do, I'm going to do the write down the KVL, Kirchhoff's voltage law, in loop 1. So loop 1, apply KVL. Loop 1, apply KVL, Kirchhoff's voltage law. So I'm going to, so while applying, all you need to do is start from one point, start walking, and come back to the same point without touching any node or any element more than once. That's the KVL. Now, here I'm going to start walking. So I'm entering the positive terminal, take that as a voltage drop. If you're entering negative terminal, take that as a voltage gain. Or if you're entering positive terminal, take that as a positive voltage. If you're entering negative terminal, take that as a negative voltage. So here it is going to be 20 times. What is the current flowing here? I1, right? So 20 times I1. Since I'm entering the positive, I'm going to take this as a positive. Now here I'm entering negative terminal. So negative times 10 I2. And then I'm entering positive terminal. So plus 10. And then I'm entering positive terminal plus 20 I1. I'm entering negative terminal, negative 20. And I came back to the same point. So this must be equal to 0. This is our loop 1 equation. So I have 20, 40 I1, 40 I1 minus 10 I2 minus 10 plus 10 minus 20 equal to minus 10. So if I take it to the other side, that will be 10. This is my equation 1. Okay, so loop 2, apply KVL. Okay, so here also I'm going to follow the current direction. So I'm going to start from here and then I will walk around, come back to the same point without touching any element or node more than once. So I'm entering the negative terminal, take that as a voltage drop. If you enter positive terminal, take that as a voltage gain. So the voltage here, since I'm entering negative 20 times, what is the current passing through this? That must be I3 minus 20 times I3 plus 10. Here I'm entering negative terminal, so minus 20 times I3 minus 10 plus 10 I2. I came back to the same point, so it is equal to 0. So I have minus 20 minus 20 minus 40 I3 minus 10 plus 10 cancel out. So we'll end up with 10 I2 minus 40 I3 equal to 0. This is my second equation. Now I have two equations, but three unknowns, I1, I2, I3. So I need to come up with a third equation. So to get the third equation, I need to apply KCL at one of the essential node. Essential node is nothing but where more than two elements connected. So if you look at this essential node here, can you guys tell me what currents are coming in, what currents are going out? At Vx, apply
Is
KCL.
I1 and I3 going in and I2 out?
I1 is coming in. Is it I2 coming out, or is it is also coming in?
Oh, that one's going in.
So all three currents are coming in, right?
Right.
I1 plus I2 plus I3, all three currents are coming in. So that is my third equation. Here we are applying KCL though. So now we have three unknowns, three equations, and we can solve for any of those currents. I'm going to pause it. So here what I'm going to do, equation 3, I will rearrange it saying that I1 equal to minus I2 minus I3. Now I'm going to put this equation 3, substitute equation 3 in equation 1. So if I substitute in equation 1, equation 3, 40 times minus I2 minus I3 minus 10 I2 equal to 10. So minus 40 I2 minus 40 I3 minus 10 I2 equal to 10. So we'll end up with the minus 10 minus 40, so minus 50 I3, minus 50 I2 minus 40 I3 equal to 10. Did I make any mistake?
I don't believe so.
Okay, thank you. I always do those silly mistakes. I'm going to say this is equation 4 here. Now equation 2 has minus 40 I3 plus 10 I2, and equation 4 has the same variables I2 and I3. So I'm going to add those two, 10 I2 minus 40 I3. Actually, instead of addition, I'm going to subtract them. This is my second equation. I'm going to subtract these two. Okay, when I subtract, this is going to be minus, it's going to be plus here. So we'll end up with these two get cancelled out. So minus 60 I2 equal to 10. Then I2 equal to 10 over minus 60, which is minus 1 over 6 ampere. Okay, what is that value? 0.166, 0.167 ampere, approximately. Negative. Okay, I forgot to put the negative there. Okay, that's a negative ampere. So what does it indicate? Since I end up with I2 value negative, that indicates that in reality, the current is going into that branch. Okay, it's not going out of that branch. Now, since I know I2, I'm going to substitute that value in equation 2. So equation 2, I have 10 I2 minus 40 I3 equal to 0. So I'm going to substitute this here. So 10 times minus 1 over 6 equal to 40 times I3. So I3 must be 10 over 40 times minus 1 over 6. So minus 1 over 24 ampere. I3 is also a negative number. That indicates that our assumption is wrong. The real current is going into that branch. Okay. Now, what is I1? I'm going to substitute these two values here to get I1. So I1 equal to negative I2, negative I3. So negative 1 over 6 minus of negative 1 over 24. So it's going to be positive value, positive 1 over 6 plus positive 1 over 24, whatever that number is. Can you give me that number? So here the total current is 0.208 amperes. So the procedure, whatever we did, we have to use both KVL and KCL to find those two currents. Okay, I used and there are three variables. So I mean, more variables, more number of equations. Solving more variables and more number of equations is little difficult. So I'm going to solve the same example by using nodal analysis and as well as mesh analysis. So there are two different ways. I'm going to solve the same example. Let me copy it. So here I'm doing the same example, but here I'm going to do by using mesh analysis, or I'm going to apply KVL, Kirchhoff's voltage law. So here in this loop, I'm assuming I1 current, and in the second loop, I'm assuming I2 current passing through this. So when I say loop, that indicates that if you take the first loop, the current passing through this outer branch is I1. In this outer branch is also I1. But when it comes to the middle branch, what I'm saying, one time I1 current is coming down, and another, I mean, from one loop I1 is coming down, another loop I2 is going up. So including both currents, you can say either I1 minus I2 is going down, or you can say I2 minus I1 current going up. Both of them are true, since current is a vector quantity. It has magnitude and direction, so we can change the direction. When we change the direction, we can change the sign. So this is nothing but, I can call this as negative of I2 minus I1, right? So that's what it is. So to eliminate the negative, I just changed the direction in the middle branch. So this is how the currents are flowing in each element. Now loop 1, I'm going to apply KVL. Now one assumption we need to make: when I'm loop 1, my loop 1 current is bigger than all other currents. So what I'm going to do, I'm going to say this is my current is entering there plus minus, current is entering there plus minus. For the sources, it's already given, so we don't need to assign any plus and minus signs. Okay, so here I'm going to start from here. Same thing, if you're entering positive terminal, take that as a positive voltage. If you're entering negative terminal, take that as a negative voltage. Okay, so plus 20 I1 plus 10. What is the current passing through this branch? Since I'm in loop 1, I'm assuming I1 minus I2. I'm going to assume I1 current is larger than I2, so it is going to be, we're going to take I1 minus I2. So I assigned this positive and negative signs based on my current direction, which is I1 minus I2. Okay, plus 10 plus 20 I1 minus 20 equal to 0. The biggest mistake I see most of the time, sometimes you may forget writing down I1 there. Okay, and it's a big error. Kirchhoff's voltage law, nothing but we are adding voltages in a closed loop. Sum of the voltages must be equal to 0. So 20 I1, 10 I1, 20 I1. So I'm going to say this is 50 I1 minus 10 I2 equal to 10. This is my first equation. Okay. Any questions so far? Okay.
No.
Sounds good. Now I'm going to take loop 2 equation, apply KVL in loop 2. Here I'm going to do loop 2, apply KVL. Now, when I'm in loop 2, I'm going to assume I2 is bigger than I1. That give me a constant equation saying that I2 minus something equal to 0, I2 minus something equal to 0. So I'm entering here. So this is positive, negative. So that's positive, negative, positive, negative. Even though this 10 ohms already has positive and negative, we do not follow that. I'm going to reassign according to my current direction. But now my current here is going up. My current here is going up, which is I2 minus I1. Based on that, I gave that positive and negative signs. So loop 2 here, the current here is I'm taking that as I2. Current here is I'm taking that as I2. So 20 I2 plus 10 plus 20 I2 minus 10. I'm entering here minus 10 plus 10 I2 minus I1 equal to 0. So that's my loop equation. So here I'm starting from here, walking through the loop. So walking through each element only once and come back to the same node without touching any node more than once. So here 20 I2 plus 10, since I'm entering the positive terminal, plus 20 I2 minus 10, since I'm entering the negative terminal here, plus 10 I2 minus I1. So when I'm in loop 2, see, it is I2 minus. When I'm in loop 1, it is I1 minus. So as long as you understand that part, I think we are good. So I have 20 plus 20 plus 10. So 50 I2 minus 10 I1 equal to 0. That's my second equation. So here I'm going to use the substitution method. So here I'm going to use the substitution method. The substitution method I'm going to take 50 I2 equal to 10 I1. Okay, or I2 equal to 10 over 50 I1. So which is 1 over 5 I1. I'm going to substitute this I2 value here. So it's going to be 50 I1 minus 10 times 1 over 5 I1 equal to 10. So 50 minus 2, which is going to be, this is 2, right? 2 I1. So 50 minus 2, 48 I1 equal to 10. I1 equal to 10 over 48. Can you guys give me that number? 10 divided by 48.
0.208.
Do we have the same number in the previous case?
Yep.
Okay, in the
Yes,
previous
we do.
case, yeah, in the I1, see 0 208. So whichever is easier. This is called mesh analysis or loop analysis. In this case, see, I ended up with only 2 equations instead of 3.
Yeah, the difficulty I was having was I was trying to do node analysis.
So since we already have I1 value, I'm going to substitute this in I2. I can find I2 equal to I1 times or I1 over 5, which is 0.208 divided by 5. Can you guys give me that number? I believe that is going to be 0.046. Is that right?
I got 0.416.
416?
Yeah.
Yeah, that could be true. I might copied it wrong. So
Yeah, that should be right.
416?
No, the 0.0416. I rounded to 0.042. So
Okay. Yeah, that 0.416. So it 0.042 is fine. Okay. So the previous case, you have I3 as negative because in the previous case, you assumed I3 is going up. That is the reason it was negative. But here you assumed I2 is going in clockwise direction, which is going down. So that's the reason our number is positive number here. Okay. So the current in the middle branch is, we can choose I1 minus I2. Okay. So if I take I1 minus I2, I1 0.208, I2 minus 0.0416. So based on this, the current flowing in the middle branch is, subtraction. Can you guys give me that number? Anyone?
I believe it's 0.166.
0.166 ampere. Okay, that is the current. So since I'm taking I1 minus I2, that means the current is going down current is going down in the middle branch. So this 10-volt source in the middle branch and 10-volt source at the end, they both are taking current. So that means they both are recharging. So they both are recharging batteries, most probably. Now, I'm going to solve this by using nodal analysis. Okay. Now I can solve, to do the nodal analysis, I'm going to do simplification. I will simplify the circuit first. So here, so far we learned that the current passing these 3 elements is same. Everyone agree?
yes.
So can I say these 3 are in series? So the 20 ohm and the 20-volt battery and these 20 ohm, everything is in series because it's the same current passing through them, as well as, there is only one element exists each node. Okay, so basically this one is look like, let me take this as A and B. I'm going to start walking from B. This is 20 ohm and then minus plus 20 volt and then 20 ohm, and this is A. Do you guys agree?
Yes.
Yes.
Now I'm going to swap these 2 elements. So the negative is on the B side, so I'm going to put that on the B side. This is 20 volt, 20 ohm, and 20 ohm. Still, it's the same circuit. So now what I can do, these two, clearly we can see these 2 are in series. Even here also you can see it, but to understand it, you may need to practice lots of examples. But probably now you can see these 2 are in series here. So I'm going to combine them, make it as one resistor.
Yep, that's what I did.
Okay, B and A. And I can do the same thing at the other end. So if I redraw this circuit, we'll end up with plus minus 20 volt. Here it is 40 ohm, 10 ohm, 10 volt, and this is also 40 ohm, 20 volt. So all three together, it's going to be, the circuit is going to look like this. Okay, now I'm going to apply KCL at the middle node, at the essential node. So nodal analysis is nothing but find out each node voltage. Okay, I mean label the nodes. I'm going to say N1, N2, N3, N4 here, and N5. In any circuit, we always take one node as a reference node. So I'm going to take this as a reference node. The reference node is always, we assume it is grounded, and that node voltage is 0. We reference node voltage equal to 0. Because first thing, ground voltage is 0. At the same time, in any electrical circuit, one wire voltage is always 0. Theoretically, practically, sometimes there is a small voltage up here across the neutral, which is not a good thing. Now once you choose this reference node, now find out if you can find voltage at any other nodes. So if you know, I mean, I want you to remember this. So if you have, this is VA, this is VB, and this is VAB. So VAB equal to VA minus VB, always higher potential minus lower potential. VA is higher potential because that is positive. Okay. So based on this principle, can I say my voltage at this node as 20 volt? Because I don't know this voltage. Let me say VA, and I know this voltage, since it is grounded, that voltage must be 0. So VA minus 0 equal to 20 volt. So this value must be 20 volt here. Same way, this value must be 10 volt there. And the same way, the voltage here must be 20 volt there. So now we know that node voltages, some of them, and the only node we don't know here, I'm going to take this voltage as Vx at node 2. So at node 2, apply at node 2, apply KCL, Kirchhoff's current law. So here I'm assuming every current is going out. So it's up to you. You can choose currents are coming in or currents are going out. I'm going to choose IA is going out, IB is going out, IC is going out. Why is that? That makes my equation a little bit easier. I know definitely at least one current must come in, right? It's just like water pipes connected together. You cannot say water is going from the junction in every pipe. There should be one income, right? Some water has to come from through some pipe. So for sure, at least one of this current is negative, but we don't know what it is. We'll find. But I will tell you why I chose that current is going out of the junction. So I, according to Ohm's law, I equal to V over R, or I equal to VAB over R, which is VA minus VB over R. So here, I mean, current always flows from higher potential to lower potential. VA must be higher, VB must be lower. That's how we will write down the current. So IA, I'm going to say IA equal to Vx minus 20 over 40 plus IB equal to Vx minus 10 over 10 plus IC Vx minus 20 over 40 equal to 0. So IA is nothing but this voltage minus this voltage. So Vx minus 20 divided by resistor, which is 40. And IB is Vx minus 10 over 10. And IC Vx minus 20 divided by 40. So I have one equation, one unknown. I can find Vx. I'm going to multiply this with 40. So Vx minus 20 plus 4Vx minus 40 plus Vx minus 20 equal to 0. So I have 6Vx equal to 80. So Vx equal to 80 divided by 6. Can you guys give me that number? 80 divided by 6.
13.3 repeating.
So 13.33 volt. Now you can find IA, IB, IC, which are the current supplied by each source. So what is IA? IA equal to Vx minus 20 or 40. So 13.33 minus 20 or 40. So minus 6.66 or 67 divided by 40. That value must be negative 0.208 ampere, similar to what we found in the previous case. I believe we got the same number. So you can see why I got negative, because I'm assuming current is flowing from Vx to 20, but in reality it is flowing in the opposite direction. So that's the reason I have that value. Okay. Now IB equal to Vx minus 10 over 10. So 13.33 minus 10 over 10. So 3.33 over 10.
I think something went wrong with
Regime recording. Okay, looks like made a mistake here. This must be 10 volts there.
yes.
Okay, so here this must be 10 volts right there. So this must be 10. So this must be 70. So 70 divided by 6. Now what is this value? 11 point. Any one of you? 70 divided by
11.6 repeating.
11.66 volt. Okay, so this must be 11.6 repeating minus 20 divided by 40. So minus 8.33 divided by 40. So we'll end up with minus 0.208. Is that right, current?
Yes.
Okay, sounds good. Now IB equal to minus 8.33 sorry, Vx equal to minus Vx equal 11.66 minus 10 divided by 10, which is 1.66 over 10. So 0.166 ampere IB. Okay, and IC equal to Vx minus 10 over 40. So 1.66 divided by 40. What is that value? 0.0415 ampere. Okay, so these are the IA, IB, and IC. So I made a silly mistake here. Vx instead of 10, I put 20. So I messed up with my numbers. So see, it leads to how many errors? Every red. So if I find in the exam a similar error, probably I might take off like 4 or 5 points out of 50. So even though you made a silly mistake like that, you will lose minimum points. But at the same time, you made a major mistake saying that instead of minus here, you put plus there. That's a major mistake. Okay, it's here it's kind of you look over the circuit. Here you do not understand the concept. So if this error occurs, I will take off -5 points right there. Okay, and then that leads all the errors. You will lose another 4 or 5 points there. Okay, so while writing these main equations, make sure you pay attention, especially the positive signs and negative signs. Make sure you understand that concept. Okay, I'm going to stop recording this one.